My name is Scott Sanderson. I am the Global Director of Business Development for AWS Energy and Utilities Industry Business Unit here within AWS. And in a few moments, I'm going to introduce to you Jordy Harrell. Jordy is the CIO, among other things, at one of our lighthouse customers called BPX Energy. He's going to talk to you about how BPX has innovated in the upstream oil and gas segment of the energy industry. So I'm really looking forward to hearing his remarks. But before we get started, I'd like to give you a little bit of context, a few thoughts about how we think about digital and energy, and kind of what the path forward might be in this environment. So first of all, digital is a theme in energy. You almost can't turn around in this business without seeing a digital symposium, blogs, white papers, publishers talking about digital innovation, talking about the cloud. It's kind of everywhere. And we're, of course, part of that ecosystem. We do a little bit of that ourselves, but so do our big partners, the Schlumbergers and the, I guess, SLB now, Halliburton's, Bakers, as well as our partners like Accenture, Gemini, and others, all talking about digital, all talking about how can we leverage cloud technologies to make the energy economy more efficient and more carbon friendly. But what really does that mean? There's a lot of jargon, there's a lot of talk. There's a lot of put your data in the cloud and do AI and do ML and you'll get insights to make better decisions. But about what, really? So I want to take it down to a little bit more of a fundamental level and talk to you about how we at AWS Energy and Utilities think about digital in the energy economy. So first I'm going to talk a little bit about how digital and physical come together. The energy industry is a very physical industry, as I'm sure you all know, but how can digital really help manage or improve the performance of those physical assets? And then Jordy will go into great detail about that. I also want to talk a little bit about how digital can improve workflows in the industry that are already data-driven, and there are plenty of them. And cloud and digital can really accelerate, improve, and create more degrees of freedom in terms of how you analyze your data. So we'll talk a little bit about that. And then we're going to talk about why is it so hard for energy companies to do this kind of innovation. We'll talk about the concept of two-way doors, which I think is very, very important. It's an important concept for Amazon. Does anybody know who this guy is? Quick test. It's a bit of a trick question. Toto Wolff. So Toto Wolff, thank you. He's not a plant. Toto Wolff is the team principal for Mercedes-Benz Formula One team. And they had a tough year this year, as some of you will know. And early in the year, it was in the morning, a Sunday morning, I was just drinking a coffee watching the pre-race, and he said, yeah, we have problems, but we believe in physics, not mystics. And what he was saying is we can't just hope away the problems that we have and say we're just gonna work harder, we're gonna digitize, we're gonna take our data, and we're just gonna make magic happen. No, they need to understand how the physics comes together with the data. And they get over 1 million data points for every lap of an F1 car going around the track. So what occurred to me is that in an F1 race, small improvements at the margin, using your data to create little pieces of opportunity or of advantage in a corner or with your tire strategy or what have you, lead to fractions of a second per lap. And those fractions of a second are the difference between winning or losing, between winning a championship and not. And so it really dawned on me that making your physical assets better at the margin is something that data and cloud have to be able to do. And of course, it is what we do. We just generally don't talk about it that way. Then you might say, well, improving at the margin, is that really transformational? Is that really enough? And what I say is I say this to a lot of our own people, it's okay to have your head in the clouds, pun intended, right? But we have to have our feet firmly planted on the ground. because the energy industry is physical, period, full stop. And that's the renewable energy side, wind turbines, solar, renewable diesel, biofuels, and so forth, as well as the legacy fossil side. Energy production follows capital, always has. Until someone invents perpetual motion, it probably always will. So we have to have our feet firmly planted on the ground and know what those systems are we're trying to improve with digital technologies and with cloud technologies. Back to the margin. In the oil business, where BPX plays, it's a 100 million barrel a day economy. A marginal benefit of 2, 3, 4%. 4% would be all of the production of BP and Chevron together, right? So even though the margin might sound small, the margin is actually transformational. In a company the size of BPX, a 4% margin could mean the difference between not having to drill 30 wells. It could be the difference between not having to spend $160 million in capital if you can make those improvements through digital. So we always like to link AWS types of solutions to these 5 value drivers in energy. How do I make more production? How do I do it for fewer dollars? How do I do it faster? How do I reduce risk? And that's both risk to personnel and risk to capital. And how do I do it with a lower carbon footprint? If our solutions can't do one or more of those things, then we're just waving our arms at doing fun things with data. So that's how we want to be much, much more pragmatic with how digital and how cloud technologies can influence and improve the behavior of physical systems. Then I also mentioned how can improve the performance of workflows, the physical assets so much right now, but think about workflows that are already data-driven, that are already executed by sophisticated knowledge workers, that are already heavy into consumption of data. I'm thinking about simulation, planning, reservoir modeling, energy trading, pricing tools if you're in the downstream side, supply chain, all of these different workflows that get executed every single day by energy companies, but today still often with legacy systems. Legacy systems where the applications and the data remain in silos. The applications cannot share the data across a platform. Cloud technologies are now making available common data sets that diverse and discrete applications can access, can consume and write to, and streamline the workflow across the entire chain. Okay? So you don't have all the discrete steps requiring their own data models. What that does is it allows sharing, it allows collaboration, and the cloud technologies themselves create a lot of ability to accelerate because we have more computing power, because we can apply high-performance computing, because we can ingest more data, because you can spin up the servers or spin them down when you spin them up when you need them, spin them down when you don't. So there's an acceleration element to that, to the workflows. So what's AWS doing about it? What we're doing within the Energy and Utilities business unit is we're creating with our partners, and in some cases with our customers, solutions. And the solutions cross the entire value chain from renewables, from generation, to transmission and distribution, to midstream, to upstream, exploration, production, and so forth. What those solutions are a configuration of our cloud technologies, our cloud kit, which continues to be innovative, along with our partners' functional software solutions, right? So we don't generally build functional software. We use partners to do that, and we enable them on the cloud to either accelerate the workflows that I just talked about, or to enhance the performance of physical assets or physical systems. And so this is just a bit of a spectrum of what we're addressing within the Energy and Utilities IBU. So why is this so hard? There's been talk for 15 years about how energy companies, whether they're utilities or whether they're oil and gas companies, are reluctant to innovate. They're reluctant to try things. They're reluctant to adopt new technologies, even if they kind of conceptually understand what the benefits could be. And we at Amazon talk about two-way doors quite a bit. And a two-way door is a decision, as the name implies, that is changeable. You can try something, you can experiment. If it works, great, then you can scale it. If it doesn't work, you can walk back through that door and try again. If it works partially, you've learned something and you can adjust on the fly. These are two-way doors. In the digital world, they're all over the place, right? We can dream 100 different things we might want to do, try, test. Might be 50 grand, might be 75 grand. If it doesn't work, we've learned something and we'll walk back. Those decisions should be made at a relatively low level in the organization so that the organization can learn. However, the energy industry is loaded with one-way doors. You can't drill 100 feet of a well and see if you're going to be successful. You've got to go all 13,000 feet. Build a 100 refinery and see if it works. You have to build the 250,000 barrel a day refinery. So the oil and gas industry and the power and utilities industry has historically had to make quarter billion dollar bets, billion-dollar bets, even in the US onshore, $50 million bets. Those aren't really two-way doors. And so the concept of two-way doors is something we're trying to feed to the energy industry as it relates to digital, not as it relates to an offshore West Africa exploratory program that we understand and we respect. But when it comes to optimizing a system, optimizing a well, optimizing a piece of equipment, optimizing a refinery, optimizing a wind farm, those are things that we can do with digital. Those are things that we can do with data. Those are things that we can try and succeed or try and maybe not succeed. The two-way doors and the digital technologies create degrees of freedom within your energy system. Degrees of freedom to make decisions that you didn't know you could make before. Degrees of freedom that allow you to possibly operate your physical assets a little closer to their design limits, within safety parameters, of course, right? Decisions that will allow your utilization and availability to maybe go up to 93, 94, 95%, 88 or 89%. And those decisions at the margin, or those improvements at the margin, create real shareholder value. But for the energy and utilities industry, it does require leadership from the top. Because of this culture of one-way doors, someone's got to say, it's okay to try it. Someone's got to say, okay, go put this on these 50 wells, and we'll see what kind of information we get. Well, let's go try this new technology and model a reservoir. We'll see if we get a decent history match. Why not try that? That has to come from the top down, because from the bottom up, the culture isn't there yet. So that's where we need you as leaders to help encourage exercising these degrees of freedom through the two-way door model. So how do you do that? You have to demand more from cloud providers. That's us. You have to demand more from your consultants. You have to demand more from your people, right? We often talk about building the muscle. And I don't know if any of you were in the executive session yesterday with Howard, where I think it was Rick Snell talked about getting people just trained on AWS isn't enough, right? You have to actually exercise the tools. You have to actually try them in the real world. You have to actually see if they work. And then that's how you learn, and that's how you get that self-reinforcement. So build that. Create a two-way door culture. And we understand not everything, in fact, maybe not even most things in energy can be thought of that way. But when you can, you need to exercise them. We talk about think big, start small, but build to scale. And I think that's what you're going to see here, Jordy talking about here in a moment. So that's what I had to say. I'm going to now turn it over to Jordy Harrell. Jordy is the CIO, CTO, and CISO of BPX Energy, and he's based in Denver. He's relatively new to the industry. He came to BPX after 25 years with Verizon as a vice president of network systems. So what he's going to walk you through is a great example of how someone who is in kind of the history and the legacy of oil and gas can innovate and turn things around. Okay? Please join me in welcoming Jordy Harrell.
Thank you. I think I have several people from my team here, so that's probably mostly where the clapping was coming, I'm guessing. Thank you, Scott, and thank you to especially the AWS for giving us an opportunity to talk about our journey and how we've been leveraging AWS for some of the innovative solutions that we've put together. Other than the color of my shirt and color of my hair, I think we almost look the same today, Scott. We didn't really plan that. Before I get started, you can see up here on the left a bunch of names. I'm not going to read through those, but everyone below Mu Lee is from my team who's contributed significantly to all of this work, and so I really appreciate everything that they've been doing. Much of the work started before I even joined BPX Energy just over a year ago. The first one, Mu Lee, very special contributor to us at BPX Energy. Mu is with AWS Energy as a principal solutions architect, but he's most importantly been with us since we started on AWS over 5 years ago, so I really appreciate everything that he has done in the larger AWS team. A little bit about myself. Like Scott said, Jordy Harrell, I'm the CTO. We also have IT and cybersecurity in our team, which we'll talk about in a little bit because it gives us a unique opportunity. I did come from Verizon. Some would ask, why would you come to an oil and gas company without any experience in oil and gas? But I was really looking for a change. I wanted a new industry. I wanted new challenges, but specifically I wanted challenges where I could dig in with the team and we could really, truly affect change as a group. And secondly, I wanted to work somewhere where I felt like they were trying to make a difference for the future, especially from a climate perspective. And I believe BP and BPX, BP who we're part of, are focused on that in a significant way. So I mentioned BP. I'm going to chat just a little bit to start about how we fit into the larger BP ecosystem. Certainly a significant drive within BP is reimagining energy. You've heard BP talk about becoming a net zero company by 2050 or sooner. We have more aggressive areas that we're trying to meet within BPX Energy and our fields here in the US. And in order to achieve these things, we've got to be leaner, we've got to be faster, and certainly we have to be focused on lower carbon activities. There are 3 strategic activities within BP around low carbon electricity and energy, mobility and convenience, and then specifically for here today, resilient and focused hydrocarbons. This is where BPX sits. This is where we are focused as a US onshore oil and gas company. We are intensely focused on delivery, but at the same time driving digital and innovation capabilities. That doesn't say that we wouldn't play in some of these other strategic activities. We actually have been involved in some recent appraisal wells for the CCUS space within the US and possibly more to come. So with BPX Energy, if you're not aware, we are basically in Texas and Louisiana for US onshore oil and gas, specifically in the Permian Basin, Eagle Ford, and Haynesville, both in East Texas and Louisiana. What's interesting also is you see that little dot clear at the top left is where our headquarters is in Denver. Some history to why it's there, but one of the big reasons is we believe that the Denver and Colorado area is a very significant source of talent, both in the traditional oil and gas job positions as well as the technology space. I'm a great example of somebody hired outside the industry and coming in to help with this type of a industry. We do, in my team, hire quite a few people from outside the oil and gas industry, focused on bringing in new ideas, new thinking around how to solve traditional oil and gas problems. We also have a team in Houston, so we're probably split pretty equal between Denver and Houston, but headquarters in Denver. So my team, I mentioned before, we have the technology, we have IT, and we have cybersecurity in the team. We are 100% cloud first capability. We have some of our own accounts from an AWS and other cloud perspective, as well as we significantly use the SaaS offerings from other vendors. We are intensely aligned with our business units and our business partners on what capabilities and applications that they need to drive the business, and having all of the technology, the IT, and the cyber in one team allows us to be more nimble, more agile, allows us to move faster in solutions, and it really drives out all of that bureaucracy when you have multiple organizations that drive each of those functions. So I've got 3 use cases today I'm going to cover. We certainly have lots of other interesting ones. We picked these 3 because they're each at a different level of maturity in our journey with AWS. The first one is migration of our OT capability into the AWS Cloud. We, over the past many years, faced a significant decentralized challenge. We had lots of field assets in the field, which made it more difficult to manage and to operate in a decentralized function. So this is a great example. Certainly there's more boxes in this, but in each one of those boxes around the middle, we had distributed, decentralized SCADA, historian, corporate systems, 3 different networks, PCN, PIN, and corporate networks as well, all distributed in each of these boxes. You can read on the right, we're in multiple states, multiple business units, over 27 contracts, high IT, OT, TCO, all the things that nobody likes are on the right side of that slide. So it created a situation where it was really difficult for us to look across our company and across our enterprise and understand where we have opportunity, and even consolidating and reporting all of that up together. Even within each of the business units or the carved off areas that we're managing their output, it was difficult there too, because even in those areas, some of the things were distributed. Truly the cost and complexity of this was staggering. So the solution we came up with, and I'll chat a little bit about the evolution of the architecture after this, was a single upstream SCADA, a single historian, significantly reduced management contracts, on-premise data center basically gone in that case. There were a few pieces left at the beginning, but they've disappeared. This allowed us to centralize this OT and IT environment into a central location. Initially, we had to separate the OT into the AWS cloud and the IT into a different cloud because of security approvals that we had to get from BP, so initially some of that was separated. What more importantly this starts to do for us is bringing, like I mentioned before, all of that data into one location where we can truly start innovating and understanding what's going on in our field. More there in a few minutes. So the initial architecture we put together was a very simple, basic solution, one account with all of the components delivered in AWS. You can see top left, field area network, everything from there fed into a transit VPC, which also served as our PIN. It connected us with the internet. We had 3 VPCs within this single account, the SCADA and historian in one, data in another, and management functions in a third. What was also interesting at the same time, through a significant acquisition of assets, and so even more pressure on meeting a date of closing for the acquisition. When you combine all that together, it's a pretty complex and difficult project to bring all of that up from the field, successfully operate from a central AWS cloud location. What was most interesting, though, is we actually met the schedule and turned this whole thing up in roughly 4 to 5 months, which I think is pretty impressive given the situation, not only the pressure of moving what you had, but taking on the new acquisition as well. So if you go back this slide, see this slide's kind of ugly, and this slide's a lot prettier. So this must be a better architecture, right? Since it looks so nice on the PowerPoint. So we've scaled this architecture since that initial was put together. We recognized that we needed additional management functions, security, zones put in place. Turned out that it would be better if we had a significant number or as needed individual accounts, which drove us to be one of the early adopters of AWS Control Tower, which you can see in the top row. And we also decided that we needed to create a separate PIN environment from the PCN environment. So across the bottom, both of those capabilities are there. And of course, non-prod accounts as well. So you see the VPC, we re-architected that transit VPC that I mentioned in the previous slide into a transit account. And then we created two different layers of virtual firewalls, which, utilizing transit gateways to help us with that. Again, all the time you're going through something like this, the most important thing is security. You cannot let your guard down on the cyber part of this, because this is what's controlling all of your field assets. So when you look at the benefits from putting this capability together, we certainly have thousands of wells now on a single platform. We have real-time analysis and optimization functions. We reduce our OpEx, which is always nice. We have a lot of real-time historical data that's available. The cybersecurity, a big jump forward. When we had all of this in the field, that was a bit of a nightmare to manage. And we did achieve a 45% reduction in IT, OT, total cost of ownership. All of those are great, but really, in my mind, this is foundational for us to now evolve this, which we have been doing over the past year or so, into a scenario where we can architect additional, larger, innovative solutions within BPX for our business partners. So that's our most mature implementation of capability with AWS. The second one is edge automation and sensing control. We have traditionally, we have over 1,000 well pads across Texas and Louisiana, and we've traditionally had an array of sensors and actuators on each of these pads, which collectively are referred to as automation typically. And all of that traditionally was dominated by the typical major players who really focused on reliability and stability, and we really wanted to focus on those things plus innovation. And so it was a prime opportunity for us to partner with AWS and make some additional changes in how we manage this edge. So certainly we wanted a more powerful edge strategy, and working with AWS, we've come up with some very interesting capabilities. What's interesting about our edge at BPX Energy, and for any of you that are energy people in the room, you know the same thing, but our edge is 4 hours from the nearest airport, 2 hours from the nearest gas station, and many times 30 minutes from the end of the power line. So we have a lot of capabilities sitting in the field which are running critical processes on solar power, private networks. We've got the vendors who are the traditional players in the field who are not typically innovating and driving us in the direction that we wanted to go, also in a high-cost type scenario. But what we wanted to do was something different. We wanted to put an architecture together that was more innovative, which was much less expensive, and also gave us really the control that we wanted at the edge. So we've been able to use, as it mentions here, hardware and sensors from outside of our industry, and we've also been able to do some interesting, more internal approaches to how we put these edge devices out. Also, kind of interesting, something that played out during this process is we started working with a vendor who was creating software and operating system software for us on the edge, sitting in some of our devices, who only have 2 customers, this vendor. Now, they only had 1 before. Now they have us, BPX Energy, and the other customer is NASA. So it's kind of cool for us because we're working with someone who really understands what an edge is that's a long, long way away. So that's been it's kind of the way we think, right? You don't have to solve all of these problems in the traditional way. You can think outside the box. You can come up with ideas and solutions that really give you the platform and the infrastructure and the framework that you want going forward. So this is the architecture we've designed. It's really straightforward. On the left, you see we have an industrial IoT device that sits out there. This architecture allows us to combine the OT and IT into a single environment. That IoT device, which might have an array of sensors around temperature and humidity and wind and methane and whatever else the case may be, feeds in through a field area network up into the cloud. Across the top are examples of latency, low latency, notifications, alarms, things like that we need to process. Also across the bottom is an example flow would be feeding into the Pi and the historian. So we have the ability to collect additional information on all of these pads now and feed that into that same data set that we consolidated and centralized in the first example. And so we can feed it into the historian, or we can feed it into a data lake, which we also have available. But we're trying to be, and we believe we've achieved it here, working with AWS, a repeatable, almost a rinse and repeat type model. So as we add functions, intelligence, and capabilities on the edge, we can just repeat this over and over again, feed it all together, and drive it from there. If you look closely at this, you notice we're not using green grass in this example. We use a little bit on the edge, but one of our significant requirements is the secure endpoints. And so at this point, we're leveraging AWS IoT core services, and that satisfied the need that we had. So in this particular example, these were 3 big drivers for us. We have these private endpoints using what I mentioned before for enhanced security. We have operations efficiency. Over-the-air updates is really important to us. When you build these devices out on the edge, you have to also be able to update, maintain them over the air. You don't want to be sending techs out to plug something in and upload a new OS or what. We've been through that in the past. Not a good situation. And secure connectivity, using the AWS IoT core was important as well from a benefit perspective. But what's special about this architecture, it brings all of the pieces that are important to us into account. Edge compute, connectivity, power, and security. So the example we just talked about was probably our next most mature solution. The last one is that at BPX Energy, we haven't done a lot of high-end and more complex AI/ML type capabilities. We do some things with our subsurface team, which is somewhat simple. And so we're really looking to break out. If we have all of this data now centralized into AWS, we have the ability to pull additional sensing data from our edge into the same data store, whether it's a historian or a data lake type capability. That now, what are you going to do with all of that? What can you now leverage and take advantage of going forward? We've recently started a project where we've turned up Amazon SageMaker. We have not used that before. I hate to admit we've been using the capability in another cloud that starts with an M also. But we are really interested in using this because with AWS, we have all of our most critical important data sitting in AWS, and we want to now start leveraging it in a big way going forward into next year. We're about a month away from this proof of concept playing out that we started about 3 or 4 months ago. We're seeing good results so far. You know, from a data science perspective, it's really important that we focus on safety, environment, production, and cash flow. These are like, you know, kind of the tenets of why we exist. And so this SageMaker Studio is going to enable us to really, I think, drive some of those interesting capabilities. This is kind of a silly slide, but everybody is trying to forecast something. And what we're doing in our proof of concept with the AWS SageMaker is a production forecasting model. T-shirts, burgers, whatever. One of the things I noticed when I joined BPX Energy just over a year ago was, so you're an oil and gas company, you would think the most important thing you would be the best at, well, probably 2 things. One is measuring what comes out of the ground. You should be really good at that, right? And secondly, forecasting what you think is going to come out of the ground. Turns out those things aren't so easy, I found out, and not because of software. So for us, in this proof of concept, we went with the production forecasting model. So this is real data from a well that we have over a 12-month period. The blue is actual production, yellow is deferment, and the green line is what we had as a production forecasting model, which is a very simple regression model. I mean, this is real. This kind of stuff happens all the time, and so it's really hard to forecast. And if you're able to leverage some of the data and models and analytics that we can use through SageMaker, you should be able to get a lot closer on this. And this is really important to be able to forecast that. On this slide, all those blue dots are representative from the previous well. You know, we could implement ourselves internally neural networks, models. They could address that, but not with the standard regressions and simple models that we've been using. And also, it's really difficult to set all this up yourself locally in your own data center or in your own servers that you have to run this, because you need to get access to the best and latest algorithms and models. You need high-end software, but just a short time each day, and you need to be able to run thousands of parallel tasks at the same time. So this is how we settled into an Amazon SageMaker implementation. So this is what we expect to happen. The red is, this is a different well, but it's a similar example. The red is real data of production, actual data. Green is what our traditional model said, and the blue is some of the data we're starting to see on how well we could improve that. You heard Scott talk a little bit earlier about the importance of being able to forecast these kind of things. It's truly significant when you think about the decisions you make every day, how you're going to operate a well, what type of maintenance you're going to put into it, what you can believe that you're going to get from a cash flow perspective and a volume perspective. So this model is pretty significant for us. Maybe we'll get an opportunity in the future to come back and talk about how well it worked. So challenges and opportunities in this use case, they're the same, but they're bad and then they get better. 30% reduction in the time it takes to deploy these models than the way we have it today. 60% model accuracy improvement. So failure identification, automated modifications, this is a significant change. And then potentially, maybe this is even conservative, a 40% ROI increase potential. This whole space around getting your data right, getting your all of your data in one place, getting clean data, just sets you up for an amazing opportunity to mine what you can out of this data and drive incredible operation efficiency, I think, not only just in drilling, but in the operating the wells, which There's a lot of bang for the buck there because these wells will operate for 20, 30 years. So having that type of a opportunity is big for us. So the 3 examples I talked about here, it's really, kind of 3 pillars when you think about getting all the data out of the field from the actual devices or the actual capabilities from a supervisor SCADA perspective, as well as taking all of the sensing data that we have in the field. I mentioned all of them, but that's just going to grow and grow and grow across the board. More and more intelligence is going to come to the pad. So when you take all 3 of these things together, you really have the opportunity to drive some incredible efficiency and innovation within this space. So all of those things together, plus what I talked about earlier about why I joined BPX, I've got a short video here that kind of shows you how all that comes together.
The Permian Basin is home to some of the world's most resilient hydrocarbons. But how does producing hydrocarbons here help BP and the world reach net zero? Because BPX Energy, our U.S. onshore oil and gas business, is transforming its operations from top to bottom through massive investments in electrification and connected field infrastructure. The electrification system, like what will be built to charge electric vehicles across America, will tie virtually all our new Permian wells into the grid, allowing us to produce natural gas with clean electricity. No generators, no compressors, no flares, and almost no sound. Next, hydrocarbons produced with 100% clean electricity will move through an interconnected pipeline network to a state-of-the-art central delivery facility, the final link streamlining our production of lower carbon natural gas for customers. And BPX is also tackling methane, a greenhouse gas over 80 times more potent than carbon dioxide while it's in the atmosphere. We're working toward continuous methane monitoring, leveraging the best available technology to measure, detect, predict, and reduce any leaks. We're even checking from space. Progress is happening. By the end of 2023, BPX expects to have electrified 95% of its conventional wells in the Permian. By the end of 2025, we'll bring 3 new central delivery facilities online, covering the rest of our assets. By 2030, we're aiming for our onshore assets to be net zero, making our hydrocarbons in the Permian a vital part of our transformation, a step toward greater energy security in the US, and a leap in progress toward net zero for the world.
Thank you. I just want to leave with one thought, and we mentioned it throughout. Don't be afraid to leverage ideas and capabilities and innovation from outside of whatever industry you work in. There's a lot of really good things that are done in parallel industries, and sometimes it's really easy to get stuck in one place. So always, I think it's important to be looking for those other opportunities. So thank you.